So if you recall, I said that there was going to be three possibilities that could happen when we consider the intersection of a line and a plane. We just found the first one where the line cuts through the plane and intersects at a single point. That happens because of what happens when we take the line and substitute it in. So you'll notice in step 2 of the last one, when we substituted it into the line, we got t equals some number, any number. So t equals 10, 15, 1, -6, even 0. If we, any number, then you'll have a single intersection point. And the reason is, since there's a single value for t, you'll only produce a single point on the line. Now, that's not the only thing that could happen when we sub the line into the plane. The other two situations could happen where it gets a little bit weird. So what would happen if they don't intersect? Then you would have this situation. The math would actually work out that it would be 0t equals 15. Or 0t equals -7. Or 0t equals 1. If you get 0t equals 10, that's impossible. Or what I call absurd. Because it's impossible if you have 0 times t and you get an answer of like 6 or 10, there's no value for t when multiplied by 0 to get you an actual number. Everything multiplied by 0 should be 0. So if you end up with 0t equals 14 or -6 or anything, that's absurd and undefined, which means it was impossible to find a value for t to satisfy that substitution, to make it allowed that the line actually hits the plane, which means it didn't happen in the first place. And so since there's no value for t, and multiplied by 0 gets a number, then this is impossible. So it's just about the same amount of work when we go off in this situation. We're going to take the line, plug it into the plane, except what will happen is you'll end up with 0t equals 10. Okay? And that's impossible, which means there's no intersection. So then what's the third case? Well, this third case then is when you get 0t equal to 0. This is possible. In fact, this is entirely possible. In fact, every value for t will satisfy this equation. 0 times t equals 6 is 0. 0 times t equals 50 is 0. So every possible value for t satisfies this equation, which means you can get an infinite amount of answers. So you take any value for t, you plug it in, you're going to get a point. And any other value for t is going to work. So when you take the line and substitute it into the plane and you get 0t equals 0, you have an infinite intersection, which means the line must lie on the plane. And it's too difficult for us to predict that. So we just do these same steps every single time. We take the line, put it in parametric, sub it into the equation, into the scalar version of the equation, solve for t, and you got three choices. If t is a number, great. Plug it in, you get a single point. If 0t equals 10, that's absurd. And then it's impossible, so you have no intersection point. Or you get 0t equals 0, which has infinite possible answers, so you have an infinite intersection of points. Let's look at an example where one of those other ones pop out. So here's the question. Again, it's given to you, this one's given to you nicely, so you don't have to do any rearranging like we did at the first to put it in parametric. It's already there. Here it is in parametric. Here's the plane. So we're just going to go right to step 2 and sub it in. So wherever we take the x, we're going to replace with, in this case, 2 plus t. The y, we're going to replace with -1 minus 2t. The z, we're going to replace with -3 minus 5t. And then a -8 equals 0. Rainbow. Lecture-like terms. So we've got 38, and this is 41, and oh, sorry, this is a minus 38t. I knew there was a pause there for a reason. I was doing something wrong. Okay, so we got 3t minus 38t is minus 35 plus 35 is 0t. And then we get 6 minus 19 is minus 13. Minus 8 is minus 21. Plus 1 is 0. So we get this, or we'll end up with 0t equals 0. So we have 0t equals 0. That is every value for t will satisfy. So since 0t equals 0, everything works. Therefore, there is infinite intersections. Remember, you are investigating the intersection, so don't just say the line lies on the plane and be done. That's great. You're right. The line does lie on the plane, but there are infinite amount of intersections, therefore.